Python's standard library contains modules for processing data in many formats, but image processing isn't really supported. For that, you need to turn to third-party libraries, and the best known and longest lived among them is the Python Imaging Library, or PIL, now known as Pillow. Pillow is for modifying image data and converting images between formats, and it uses a library written in C for fast processing. It's not for displaying images. For that, you can just use the image viewer in your OS, but it is for manipulating images as data, changing their sizes, compositing images, stitching them together, saving them in different formats. So let's take a look at some simple examples of Pillow in action. When you open an image for processing in Pillow, like this, the image is read into memory and decoded into an uncompressed bitmap. The larger the image, the more memory it's going to take up when uncompressed, and the longer it's going to take to perform any particular manipulation with it. This is worth keeping in mind if you're doing batch processing, for instance. Once an image is loaded, you can obtain all kinds of statistics about it, its size in pixels, or what kind of color mode it has. RGB is the most common color mode that you'll see, typically in images like JPEGs, but you may also see RGBA for PNG files or other file formats that have an alpha channel. The color mode is important since some kinds of image manipulations can only be performed on images with certain color modes, but this is a more advanced topic that I can go into in a future video. It's just worth noting for now in passing. A common image manipulation is to take an image and generate a smaller or thumbnail version of it. Pillow comes with a built-in method called thumbnail to do this with a given image, and this is a good way to demonstrate how the built-in methods work generally. You supply it the maximum size of the image along either axis, and thumbnail will transform the image to fit into a rectangle of that space. Note that thumbnail works on images in place. It doesn't return a copy, rather it resizes the original image. Note that I'm not talking about the original image on disk, but rather the image that we have loaded into memory. So this is also a good point to talk about one of Pillow's potentially frustrating behaviors. Some of Pillow's methods work in place, and some return copies. So you need to check the method signature for each method to see what happens. Now, since thumbnails work in place, if we wanted to work on a copy of this image, we could do that by just using the copy method for an image to generate a copy, and then we would do our work on the copy. The original would only linger in memory as long as some reference to the original stayed in scope, as with any other Python object. Now, you can also obtain pixel data for an image and do direct manipulation on it. But doing that at scale in pure Python does tend to be slow. Here's an example, though. I use the load method to generate what's called a pixel access object from the image. And I can iterate through it or access it with XY coordinates, and I can make changes to the RGB values that I find at each coordinate. And when we do so, this gives us a differently toned version of the image. Now, for an image this small, pixel access is not going to be too slow, but it's always best to use Pillow's higher level methods when possible. With Pillow, most of the image manipulations we'd want to do are handled with high level constructions. We've seen thumbnailing, for instance. If we want to rotate or transform images, there are built-ins to do that. And since they return copies, we can assign the results to a new name to work with them further. In this case, our original image is getting rotated and returned as a new image, and so we can make a thumbnail with that new image. Another class of high-level Pillow method is for when we want to alter colors, brightness, gamma, or other overall image properties. And again, the way this works programmatically can vary a great deal from module to module inside Pillow. Some of why these methods are so convoluted is because Pillow and its predecessor, PIL, have been around for a long time. These are basically legacy behaviors. For instance, Pillow's image enhance module can be used to make changes like the ones I described, like altering its overall brightness, but it doesn't behave like either of the examples we've shown so far. So in this example, I'm going to do that with an image after I make a thumbnail from it. But you'll notice how this image enhance.brightness method, it takes in the image object as a parameter, and then it returns another object, which we then use a generic enhance method on to actually make the change. And that method, in turn, returns our altered image. And as you can see, this new altered image is much darker than the original. So this set of steps is a lot more convoluted than anything that we've seen before, and a good example of how Pillow can be deeply inconsistent internally. Finally, you can also use Pillow to save images back out to files. For this example, I'm taking the image I rotated and converted to a thumbnail, and I'm saving it back out to another JPEG. Each of Pillow's supported codecs, like JPEG or GIF, have different save options. For instance, with JPEG, we can use the quality keyword argument to alter the compression level for the saved file. So to sum things up, Pillow provides tools for working with common image formats using a Python interface around a fast C library. Almost every common image manipulation procedure you could want has a nice high-level API, resizing, compositing, changing image parameters, and so on. But you need to read each method's documentation closely. Pillow's methods have a lot of inconsistencies in how they're invoked. But in future episodes, we're going to dive deeper into advanced image processing with Pillow, and we're especially going to be looking at using it with tools like NumPy and Cython to get maximum results. So that's it for this episode. If you liked it, leave a comment below. And don't forget to follow Dev with Serdar and InfoWorld on Facebook, YouTube, and Infoworld.com.